Welcome friend. Again we have to discuss our subject, that is calculus first. In the previous lecture we discussed definition of sequence, then some examples on the sequence. So what is sequence? Sequence is just a function from natural number to the set. Is it? Sequence is just a function from natural number to the set whose range is subset of a codomain, we can say. It is simple. And we see some examples on the sequence. For example, constant sequence 5, we already discussed this. In the today's session, we have to discuss the limit of the sequence. We discuss first definition of a limit of a sequence of real number. Then we discuss about the convergence and divergence sequence. Then we take some theorems on limit of the sequence. So we start our topic, that is limit of the sequence. Sequence of real number. We are discussing all the sequences of a real numbers. So first we write the definition. First we write, let x is equal to xn is a sequence in a set of real number R. Then we say that the real number x is a limit of a sequence x if for every epsilon greater than 0 there exists a natural number k epsilon such that for all n greater than or equal to k epsilon the term xn satisfy mod of xn minus x is less than epsilon. Okay. So what is the definition of sequence? First we take a sequence in a real number. Then we say that the real number x is a limit of a sequence x if for every epsilon greater than 0 there exists a natural number k epsilon. K epsilon means there k is depends on epsilon. Okay, such that for all n is greater than or equal to k epsilon the term xn satisfy mod of xn minus x is less than epsilon. Okay, then the limit is of sequence is denoted by limit of sequence x is equal to x, or we can write limit xn is equal to x, or sometime we write xn tends to x, means what it means, xn approaches to x as n tends to infinity, as n tends to infinity. That means limit xn is equal to x, or limit of x, sequence x is equal to x, or we can write xn tends to x. Here limit is always what? In the previous we write here n tends to infinity, but in this here it is not mentioned always n tends to infinity. Why it is? Because sequence always limit tends to infinity, that is n tends to infinity. Is it? Sometime it will be written, or sometime it is not written in our book, they are not written here, but you have to say, or you have to write this is n tends to infinity, okay, for your convenience. Okay, if limit is n tends to infinity is not given, you have to understand that this is the limit of sequence, therefore it must be n tends to infinity. Okay, then some next point we have to keep in mind, the convergent sequence. The sequence has a limit, then we say that the sequence is convergent. Okay, that is, if the sequence we have a sequence x, is it? This sequence x is equal to xn, it is convergent. When it is convergent? If it has a limit of the sequences exist, then we say that it is convergent. And if the limit of a sequence is not exist, then it is divergent. If the limit of the sequences exist, then we say that this sequence is convergent, and if the limit of the sequence is not exist, then we say that this sequence is divergent sequence. Okay? Okay. And one more point we have to return, that is, we are written here k epsilon, but from the next time or in the remaining chapter we are not writing always k epsilon. Is it? We are writing just k. That is, from now we write k epsilon is equal to k, where k epsilon means k depends on epsilon. Is it? K epsilon means what? K depends on epsilon. Epsilon changes, k b changes. Is it? So instead of k epsilon we are writing now k. Is it? Okay. So what we see here, definition of sequence, then convergent sequence, limit of exist, then we say that this sequence is convergent. Limit is not exist, then we say that it is divergent sequence. And instead of k epsilon we are going to write now k only. Is it? Okay. Now we prove some theorems on limit. First theorem we have to prove uniqueness of a limit. So first theorem is uniqueness of limit. So what is the statement? A sequence of a real numbers of real numbers have at most one limit. Proof. So question may be asked, state and prove uniqueness of theorem, or prove the theorem a sequence of real number have at most one limit. Okay, so we will try to prove this. So let or suppose the sequence x is equal to xn in R. The sequence x is equal to xn is in R. Let this sequence x has two limits, x1 and x2. x1 and x2. Suppose what we can say, there are two limits. Then what is our target or what we have to prove? So our claim must be x1 is equal to x2. We consider two limits, then we have to show that these two limits are equal. Okay, so use the definition by the definition of limit of a sequence. So what we can write by the definition, for every epsilon greater than 0 there exists a natural number, k epsilon, we are writing k, natural number k, such that what, mod of xn minus, what we can write, mod of xn minus x1 is less than epsilon by 2 for all what we can write, n is greater than or equal to k. So we have two limits, we have to write two definitions. So we are taking here k1 and this, therefore we can write here n is greater than or equal to k1. So we write the definition for the limit x1. Similarly we have to write the definition for x2 also, and the natural number k2 such that we are writing both the definition in one, we are taking one epsilon only. The natural number k2 such that mod of xn minus x is less than epsilon by 2 for all k2, or we can write n is greater than or equal to k2, for all n is greater than or equal to k2. Okay, so now what we can take, let what k is greater than k1 and k2, hence we get for every epsilon greater than 0, from this we are writing it is in the both, for every epsilon greater than 0 there exists a natural number k such that what we can write, we have to write first statement, this is mod of xn minus x1 is less than epsilon by 2 for all k is n is greater than or equal to k, and and mod of xn minus x2 is less than epsilon by 2 for all n is greater than or equal to k, and say this is our star equation. That means we take or we choose k is greater than both k1 and k2. So this definition we are written, it is in the form of k again. Now we have to prove x1 is equal to x2. Okay. So for this what we can do, consider. What we have to consider? x1 minus x2, it is equal to. So what we consider? Mod of x1 minus x2. So what we do? We have to add and subtract x1. So x1 minus xn plus xn minus x2. So what we did? Add and subtract xn. So now we write or we use the triangle inequality by triangle inequality. So what is triangle inequality? Mod of a plus b is less than or equal to mod a plus mod b. Okay. Similarly for subtraction. So what should be this? Mod of x1 minus xn plus mod of xn minus x2. Okay. This can be written, it is in the form of, we can write it is equal to, what we can write, or we can write it is less than or equal to mod of xn minus x1 plus mod of xn minus x2. So what we did here, this mod of a minus b is equal to mod of b minus a. We use this property. Then what we can write, but this is strictly less than what? Epsilon by 2, and this is also strictly less than epsilon by 2, which is equal to epsilon, and that is what we can say, mod of x1 minus x2 is less than epsilon. But what? But epsilon is greater than 0 is arbitrarily small. Hence what we can write? Hence mod of x1 minus x2, it is equal to 0, and this can be rewritten x1 is equal to x2. Therefore x1 is equal to x2. This epsilon is very small. Therefore this term, this difference must be 0, and therefore we can say that both the limits are equal. Okay. So what we did here, we write just the definition of the limit of a sequence. So it is very important to understand the definition or keep in mind the definition of a limit. So what we did here, sequence of a limit have a at most one limit. We consider two limits and we have to show that they are equal. So what we did, first we write definition of a limit of the sequence is x. So first, for first limit we consider k1. Why here we are taking epsilon by 2? Because here we need epsilon by 2 plus epsilon by 2 is equal to epsilon. Is it? That is the reason what we take here epsilon by 2. Is it? Or you can take here different symbols also. Okay, this is no problem. But we take here epsilon by 2. Similarly for x2, this should be x2. This should be x2. Okay, and the natural number k2 such that mod of xn minus x2 is less than epsilon by 2 for all n is greater than or equal to k2. Okay. Therefore, what we can take, k is greater than k1 and k2. Therefore, we write this definition for k, and then we are written here. What we did here, we are considering x1 minus x2, and this is, we show it is less than epsilon, but epsilon is very arbitrary small number. Therefore, we can say that this difference must be 0, and therefore both the limits are equal. Okay. Now we will prove one more theorem on the limit of the sequence of real number. So what is theorem? First I read. Let x is equal to xn be a sequence of real numbers and x belongs to the R. The following statements are equivalent. So x converges to x, that is the sequence x converges to x. B statement is, for every epsilon greater than 0 there exists a natural number k. For all n greater than or equal to k, the term xn satisfies the mod of xn minus x is less than epsilon. Then for every epsilon greater than 0, there exists a natural number k such that for all n greater than or equal to k, the term xn satisfies x minus epsilon is less than xn is less than x plus epsilon. Then one more statement D, for every epsilon neighborhood v epsilon of x, there exists a natural number k such that for all n greater than or equal to k, the term xn belongs to v epsilon neighborhood of x. Okay. So we have these four statements and we have to prove all the four statements are equivalent. So what we have to prove? We have to prove, what we have to prove? A if and only B, if and only if C, if and only if D. That is we have to prove. So first we prove A is equivalent to B. Okay, A is equivalent to B. So what is the A statement? What is A statement? X converges to limit x. What it implies? Both way implication we can write. X converges to x means what? The sequence x has a limit x. That means what? The sequence x has a limit x. Is it? Convergence to x means it has a limit x. Okay. Then what we can write? And therefore by using the definition of the limit, what we can write? If and only for every epsilon greater than 0, there exists a natural number k such that what? For all n greater than or equal to k, the term xn satisfy mod of xn minus x is less than epsilon. It is the second statement. So very simple proof. Just we have to write the definition of a convergence of a limit of a sequence or limit definition. Okay. So what we can say, x converges to x means it has a limit x. Then this implies that when it is possible if the sequence has a limit x, and this is just the definition of the limit. Okay. So now what we have to prove? Now we have to prove. Now what we have to prove? B if and only if, C if and only if, D. Okay, we are going for the next part. Before this we must know the definition of a epsilon neighborhood. So epsilon neighborhood, suppose V is a epsilon neighborhood of x, it is equal to what? It is the set of all point A belongs to the R such that mod of x minus A is less than epsilon. Already we discussed this definition. Okay. So what we can say? Now our second statement is what? For every B implies, what is B our? For every epsilon greater than 0, there exists a natural number k such that, or for all k greater n is greater than or equal to k, the term xn satisfies mod of xn minus ax is less than epsilon. And what it implies, use the absolute function property. What this implies, this is nothing but our what? Use the property minus epsilon is less than xn minus ax is less than epsilon, and if and only if add all x here, x minus epsilon is less than xn is less than x plus epsilon. So what we get? We get a statement C. So from B2 we get a C. And what is this? What is this? That means all the term lies between the, or this say that all the terms xn is in the neighborhood V epsilon neighborhood of x. Is it? That means what? All the term xn lies in the epsilon neighborhood of x. So this is the proof of this theorem. Now what this statement shows? What this statement shows? The meaning of this statement is nothing but the definition, meaning of the definition of the limit of a sequence. So xn converges to ax means what? Xn has a limit x, and xn has a limit x. What it means? There exists a neighborhood, epsilon neighborhood of ax, in which all the terms xn lies. All the terms xn lies after the number k. That means some terms, that is x1, x2 and so on up to the x k minus 1. That means x1, x2 and so on xk minus 1. These terms may not lies in this neighborhood. Remaining all the terms lies in the neighborhood. Then we say that this sequence has a limit x. Okay. So what we see in the today's lecture, definition of a limit of a sequence, some theorems on sequence limit. So thank you very much.